Hi everybody, my name is Andrew Valinas. I'm with the Montana Renewable Energy Association. MREA is a nonprofit organization based here in Montana that educates and advocates about all things renewable energy. Today we're here in sunny Missoula, Montana. We're going to be looking at a solar PV system. We're going to walk through the components, talk a little bit about what you as a homeowner might be interested in thinking about and discussing as you get ready to go solar. With me here today is Dan Brandborg from SBS Solar. Thanks for joining us, Dan.
Absolutely.
Dan, why don't you tell us a little bit about kind of your background and what you do?
Okay. Well, the owner of SBS Solar. We serve the Missoula, western Montana area with photovoltaics. Our base is in Hamilton. Been doing it for quite a few years, 33. But with Sinelco down to Bitterroot and Missoula and the on-grid systems in Missoula now is really our big focus, residential and commercial.
Great. Well, thanks again for joining us, Dan. We're going to be picking Dan's brain today. We're going to walk through, like I said, all the different system components and teach you about what those are. But Dan, before we get there, what do you go over with a customer? What are some of the preliminary considerations you should have when you're thinking about this stuff?
Yeah, so the first conversation is power use. A power bill is very helpful. We've got kilowatt hours used on a monthly basis, and we tally those up to get an annual figure of how much power we use. That really helps us line into size the system. And second would be the solar access. Can we be on a house, on a garage like we are here? Do we need to do a ground mount? So we can do a lot of work with Google Earth. We can measure your roof to a couple inches. So we like to do that homework and be ready for that when we come and see the homeowner. And then we can really talk details and get an idea, rough cost of sizing and such.
Great. So it seems like the first step is just kind of assessing what the potential is for producing power and how much you might need, and then kind of going from there, right? And you talked about roof and the solar resource on the property. What's the best direction? When you're looking at roof angles, is it okay to fudge it a little bit if it's not directly south-facing? We hear a lot about south-facing. Right. How does that work?
Well, south-facing is optimum. 180 degrees and about 34-degree pitch is the magic number for Missoula, Montana. But that's not the real world. South-facing roofs, we can vary a little bit. With the reduction in cost of the modules in the last so many years, east and west-facing roofs are very applicable. The lower the pitch, the better it is, because we want to get that morning and afternoon sun. But so south is first, if we can utilize that area, and then we'll go to other aspects.
Great, great. And you mentioned when we're looking at these energy bills to kind of understand the energy use and how much you want to offset with solar, you look at it on an annual basis, right? Because it's beautiful here today in Missoula, but Missoula gets some pretty cloudy winters. Right. The northwestern part of the state is the same. Over in the eastern part of Montana, maybe it's a little sunnier throughout the year. How does that annual production work?
Yeah, we have the net metering where we're taking our power in the average grid tie system, and a day like today, we're powering the house and we're exporting power. So as we export power, we're leaving a credit on that meter, and we can use that tonight or we can use that in January. So we really have annual solar storage with a grid tie system, which is a huge benefit because our variation in sun in Missoula and western Montana is huge, where, like you say, we get into Billings and we don't see this real reduction. We get so much precip and snow here that the winter months do a fraction. My number is a January day is about 1/7 the amount of power of a June day. So you can see our importance is summer and spring, fall. Winter we're not too worried about, which gets to snow removal, which is why we're there. Do we need to remove snow from the panels? I say don't worry about it. You're not losing that much. In this case with Eric and Abby, they could remove some snow here, and that would help. We get those beautiful blue days in December too, once in a while, right?
Sure. And that is the nice thing about solar, and we'll be going into the components here shortly, but once you put them up on the roof, other than pushing some snow off if you want to, there's no maintenance. They just sit there and produce nice, clean, resilient energy right into your meter.
Yeah, that's the fun part of it. It's the only maintenance would be monitoring. Once in a while, make sure it's on. Make sure that green LED is on. The systems we're installing now, almost all of them are connected to the internet. So you got it on your smartphone, you got it on a computer, you can really analyze what's going on. So there's our maintenance, is did a breaker get thrown, or somebody throw a disconnect switch, and that's it. Otherwise we're pretty light duty.
Otherwise it's just the fun part of watching the energy be produced.
There you go.
Great. Well, let's go ahead now and take a look at some of the components. We're going to walk around and show you the different elements and mechanical pieces that do go into this entire system. So now we're going to take a look at the actual solar panels themselves. And Dan, behind us here, we've got a solar array, obviously producing the energy from this entire system. Why don't you talk us through a little bit about how these panels work and what the key components are?
Very good. So there are three major components to a system: modules, solar panels, the mount structure that holds the modules to your structure, your ground, or your roof, and an inverter. Basically, those are the three main items. We've got some wiring conduit as well. So let's talk about the panels for a second. Here we have 10 355 watt modules at a really good pitch angle, and it happened to be, as you can see, this garage. We selected the garage because the house has some beautiful shade trees on the southwestern side. So this is our most, I call it, valuable real estate on the property to employ modules. A lot of people are confused between cells and modules. We have 72 cell modules here, monocrystalline. The cells are arranged in series, and they put out around 40 volts. So we string those together and come up to a pretty high voltage nowadays, 300, 400 volts. And then that power comes from the modules into the inverter, and the inverter does its job of changing that DC power from the panels to AC power, 240 volt that we're used to and we use in normal homes. So that's our module. So the other thing I'd like to cover here, this is a great example system, and the reality of it is shading. One of the negatives of photovoltaics is shading. Branch of a deciduous tree is in wintertime, no leaves, is still a factor. So any kind of shading, the modules are very sensitive to it. So we've got a little shading going on. Now we've cleared up here in the last half hour, but you see how the tree just has grown, and so we got a little issue there. So we can't quantify just how much power we're losing, but it's significant when you look at that little bit of shade. But for that one module, it's significant. So if we can stay away from shading, that's our job, especially from 9 o'clock until 3 o'clock. Those are our really essential hours for production. Earlier and later in the day, it's not so important because the sun's coming through so much atmosphere anyhow, it's diffused. But boy, when we're around noon, 10 to 2, 9 to 3, that's when we're making our power.
Great, great. And like you said, these panels are wired in series. That those are the things actually producing the energy, which are converted from DC to AC at the inverter. Talk us a little bit about panel sizing. From what I've seen, panels are typically the same size-ish, but the technology has gotten better over the years, right? I mean, this same size panel a decade ago wouldn't produce nearly as much power as it does now.
Right. A decade ago, this would have been 200 watt modules. Now they're 355. This year, we're up to 400 watts per panel. So we're seeing a gradual increase in the efficiency of the cells. We're about 18% efficient here as far as converting sunlight directly into electricity.
Okay, so we talked about the panels and how much power they can produce. How do we get them up there? And obviously we've got a nice sunny roof here like we talked about. What if you don't have a sunny roof in your backyard? You're dealing with some of those shade issues. Are there other options than putting it on a roof?
Absolutely. The roof is the most popular because of cost, and we already have a structure, so we can utilize that structure, tie into the structure of the roof versus ground mount, which is going to be more expensive, but some places that's the way to go. It does have advantages. It's down lower. But we've got to employ concrete, steel. We need to trench that power in. So we got more costs when it comes to ground. So the number one thing you see is roof mount, just for that reason. So we just have a series of rails there going east-west. We're tying down with some bases or feet that are waterproof. We do not want to make any water intrusion, any kind of leak issue. And we've got some great components to do that. And then we tie the rails in, and away we go.
And the nice thing about putting it up on the roof, as opposed, well, it'll protect your roof to an extent, right? I mean, there's some trade-offs there, I think. With the ground mount, the nice thing is you can put it anywhere on the property where there's sun. Right. So you have maybe a little more freedom with the location. But one of the perks I've heard is that if you put up a rooftop solar system, it actually protects your roof for a while. And these panels themselves are pretty resilient, aren't they?
Oh, they're very resilient. If they were down ground level, we'd kick at them and show it's tempered glass like the windshield of a car. They're very tough. They are designed to take hail, 1-inch hail at 90 miles an hour in a perpendicular angle. Very, very rare that hail would take it out. We do say put your system on a homeowner's insurance just in case.
So Dan, we talked a little bit about how it protects your roof, but in order to get it up there, you got to make sure your roof is strong enough to hold it, right? Can you talk a little bit about kind of how that works with solar panels?
For protecting your roof, what we're doing is blocking those UV rays from hitting that roof material, the asphalt shingles, which have got a useful life period, right? We're going to have to replace them sometime. It's always a good idea to have the roof age kind of equaling or exceeding the 25-year warranty of the modules, so we're not having to take the modules out, re-roof. But like Andrew points out, the shingles that are behind the modules are running a lot cooler. They're out of the direct sun, so they do last longer. But then the perimeter around the edges, we're still getting full UV. So the modules are mounted a couple inches off the roof surface because of cooling. We want the solar cells to run as cool as possible. They're a semiconductor. The more cooler they run, the more efficient they are. Weight is also a common question. These panels are about 45, 47 pounds apiece. So we're looking at about 2.5 pounds per square foot additional weight to the roof, which is pretty light. You know, a lot of folks say, wow, how heavy duty is that? With standard building codes today, and we do all our homes in Missoula County go through a structural review by a structural engineer. If we have newer trusses in the last 30 years new, we're good to go because they're built for the existing code and snow loads.
Great. And I know that is a consideration. I know I tell people as well, if you are considering redoing your roof or need to redo your roof, obviously that might affect cost if you've decided to go solar first. If you haven't decided to go solar yet and you're redoing your roof, it's a great opportunity to make sure there's just an incremental cost that you can add into that project to make sure it could be solar ready later down the line. Well, great. Well, let's go ahead and move on to our next component. We're going to talk about the inverter next and how that plays into the rest of the system.
So here's our inverter, the third major component of the system. We have our solar power DC coming in. We invert to 240 volts, and then here's our output, 240 volt power going to the house distribution system and a disconnect switch. We have a monitor on this unit, which is really fun to see. We've got the lower mod number here is 10 over 10, or 010 over 010. That means all 10 modules are producing. Upper right-hand number is the big one, 2,300 watts is what we're making right now. We can go in and look at more historic data and such. It, again, feeds into the internet, so we have larger amount of data there. This is a unit that's very maintenance free. It just turns off at night, turns on the next day with the solar. Very few moving parts and good longevity and really high efficiency. We're at 98–99% efficient from DC to AC.
The last component we need to talk about now is the meter. This is your digital utility meter, and it's a net meter. There's more information about net metering policies on MREA's website, but we're going to talk about the physical net meter right now. Net meters measure direction of energy flow in both directions. Your standard utility meter will only measure energy coming into the home, but now that we have a solar array on the premises, we're exporting energy to the grid, so we need to measure directions of flow in both directions in order to account for the total energy use, both used in the home and exported to the grid. Our system set up here, we've got the wiring coming in from the inverter right here from the solar array, and it's coming into this AC disconnect switch. This is an emergency responder tool that they can use. It's kind of a feel-good switch that they can pull in order to do maintenance on the system or potentially during a blackout or something like that. We have the main panel for the home here, so that's what's coming in up to the panel box, the breakers. And we've got the utility grid up there going out to the grid or coming in. What we've got right here is where the solar array comes in, the solar system disconnect. So we can flip that switch as well. It's another way to disconnect the system if we need to. But again, the nice thing about solar panels is that there's no maintenance needed. Once the panels are up on the roof, homeowners shouldn't have to touch any of these components. You just let the energy flow in and out of the home. Now, one of the neat things about these meters is that up here you can actually watch the energy flow in two different directions. There are these little dots in the bottom right-hand corner, and you can see the dots flowing this way, meaning energy is exported to the grid. Energy is being sent from your solar panels through your home, and since there's excess, it's flowing out to your neighbors. Now, if the dots were flowing the other way, you would know that the solar panels are not producing enough energy to cover all of the needs in the home, so the grid is producing that energy, and energy is flowing in from the grid.
So my name is Eric.
I'm Abby.
And we're proud owners of this system. And it was just really great to work with Dan and SBS. He walked with us every step of the way and did just a great job. We couldn't be more pleased, I think, with the final product and what it's really given to our home. I know I've fielded many walk-bys, as we call them. It's just been terrific to see people walk by our house and see solar and say, wow, that's so awesome that you're doing that. Like who installed those panels, or how can I do the same thing? And as a homeowner, it's just awesome that it both inspires people, but then adds, I think, value to your house. Not only monetary value, but value in your neighborhood, and doing our part.
Yeah, it's really been great to have solar on our home. Something really tangible. You know, not everyone has the privilege to be able to go solar, but we did, and we felt like that was a really concrete step that we could take as homeowners to, like Eric said, do our part and to feel like we were contributing and putting more clean energy onto the grid. And if everybody who could go solar did, we know that would make a big difference in moving towards really important sustainability and climate goals for our community too. So it's all around an awesome thing, and we have been really, really pleased with the experience.
Well, we've taken a tour of the system now, walked through all the different components. Dan, thank you so much again for being with us.
You bet.
Any other closing thoughts on other things to consider now that we've got this great solar array at our home?
Well, one thing we didn't cover was efficiency, home efficiency. So that's key to solar. If we can reduce the electrical loads in the home, we reduce the size of the system, the cost of the system. So LED lighting, of course, incandescent bulbs are 8 times better producing heat than they are producing light. So bye-bye incandescent. Efficient newer appliances with federal standards, they need to be much more efficient. So 10-year-old or less appliances consume a lot less power. And then the two big loads in the house: heating, cooling, and hot water. In this case, especially in the Missoula market, we have a lot of natural gas. So heating is typically natural gas. The only heating system that we can really take on when it comes to solar would be a heat pump to run the whole heating system of the house. And then the hot water, as Eric and Abby have done here, has replaced that natural gas hot water heater and pulled it to electric so it could be renewable. And we've got a heat pump integrated in the top of the hot water heater, and it's fun to see 1/3 of the amount of energy to produce your amount of heat, hot water you need in a year. And the other point we just might say is that we size a lot of systems today for like 95 to 98% of the power usage. And our job is to undersize the system to your loads slightly. So if we produce more power and export more power than we import over a year's time, the utility will take that power and not reimburse us. So it's kind of our job to make sure, and that's why we analyze the power bill so much, and it's so key to everything.
Great. Well, thanks, Dan. And we went through a lot today. Obviously, the different system components. There are a whole lot of considerations. One of the things MREA always recommends is calling up your installer and asking, because you guys are clearly the experts. So thank you again, Dan.
You bet.
And we look forward to learning more from you in the future.
Sounds good, Andrew. Thank you.
I'd like to thank Dan Brandborg with SBS Solar for joining us today and for sharing his expertise. And of course, thank you all for tuning into our video. We hope you learned a lot today. Don't forget, there's a lot more you can learn, and you can do so by going to MREA's website, which is montanarenewables.org. We have tons of information on solar, net metering, and many more interesting topics in renewable energy. Thank you.